We're going to learn how to solve absolute value equations in which the variables appear on both sides, and the absolute value equations will lead to linear equations. So in a previous lesson, we learned how to solve this type of equation where we had the absolute value of 3x plus 2 is equal to 5. So when we got the absolute value by itself, and if this was a number here, no variable, but just a numerical expression, then and this was positive, then we knew that we would have two solutions. And the way we learned how to find those two solutions, two distinct solutions, was to uh, think about the definition of absolute value. So so this expression right here, we're saying this expression, the absolute value of this expression has to equal 5. In order for that statement to be true, in order for that statement to be true, in order for that equation to occur, then then if this is positive right here, whatever I substitute for x, if that turns out to be positive, then I can just say that this linear expression has to equal the other side. So 3x plus 2 has to equal 5. But then we know that depending on what I substitute in for x, this value right here could be negative, right? And if I want this expression right here to be equal to a positive 5, then and this is negative, then we also knew that we had to take the opposite of the other side. Because if this is negative, then that would imply that those two, 3x plus 2 and 5, are opposites. So then we have to use the idea of opposites. So 3x plus 2 has to equal to the opposite of 5. All right, and so that came from the definition of absolute value, the idea of absolute value. And then what we did was we just solved each linear equation. And so you get 3x equals 3, and then x would be 1, right? And over here, subtract 2 from both sides, we get 3x equals negative 7, and x is a negative 7/3. All right, and so those would be your two solutions. And we saw that if this number is negative, if that number is negative, then you know that this equation would never be a true statement no matter what you substitute for x. So, because remember, the absolute value of that expression here has to either be positive or 0, right? It has to be positive 0, never negative. So we had some examples in a previous lesson that if this was negative, then we would say no solution. If this was 0, you just have one solution. All right? And so all of that came about from that idea of the definition of absolute value. But the goal here is this, though. So here's the goal. How do we deal with this kind of situation? What if I want to solve the absolute value of 3x plus 2 is equal to, so instead of saying the absolute value of 3x plus 2 equal a positive number, what if we had this? Equals to 4x plus 5, right? Okay, so what if I had that? Well, that same idea applies, by the way. That same discussion we had here applies here. But remember in the previous lesson, we knew that if this number right here was positive, I had two solutions. If that number was 0, I had one solution. If that number here was negative, I had no solution. But here, it's not so easy to determine because this right here, since that's a variable expression, depending on what I substitute for x, this could be positive. For example, if x is 2, 4 times 2 is 8, 8 plus 5 is 12. It could be negative. If x is negative 2, 4 times 2 is negative 8, negative 8 plus 5 is negative 3, or it could be 0, right? So either positive, negative, or 0. But remember our definition of absolute value. So the definition of absolute value says this. So the definition of absolute value says this. So I'm going to write it as this notation. So remember, if the absolute value of, let's say we have 8. So this number is 8, right? So that number is greater than 0. So if that number is positive, we know that the absolute value of 8 is equal to 8, right? So if this expression, which is x, so if that is positive, then we know that the absolute value of x has to equal x. So if this is positive, then the absolute value of x has to equal x, just like it was here. The absolute value of 8 equals 8. If this, and we know that the absolute value of 0 is equal to 0 if x equals 0, correct? I'm sorry. Oh, yeah, I mean, I could use the idea of x, but of 0, let me write it like this, because the absolute value of 0 is equal to 0, because 0 equals 0. Um, so if x equals 0, then the absolute value of 0 is equal to 0, correct? And if x is negative, let's see what we did if x is negative. So if x is, let's say, a negative 8, then we know that the absolute value of negative 8 is equal to 8. But I want you to look at those two numbers here. What do you notice about those two numbers, negative 8 and positive 8? Those two numbers are opposites, right? Those two numbers are opposites. So if x is negative right here, if x is negative, then what I've got to do is this. So here's how you got 8 right here. So you had negative 8, and what you had to do is take the opposite of negative 8. So the absolute value of negative 8 is equal to the opposite of negative 8, which is equal to 8. And that's how you got this. So what we have to do here is that if x is negative, if this value in here is negative, then the absolute value of that, I would have to take the opposite of that value. Okay? And so what we're going to do when we get to this equation right here is we're really going to look at the first two situations where x is positive and where x is negative. So where this expression is positive and where this expression is negative. All right, so remember, if this expression is positive, then this and this have to be equal. If this expression is negative, then those two situations here are opposites, so I have to take the opposite of this. Okay? All right. So here's what we're going to do. So let's think about how to deal with this. All right, so I have the absolute value of x plus 2 equals 4x plus 5. So remember, this could be positive, negative, or 0. But I want to know what values of x will make these two sides equal to each other. Okay, so let's think about this. If this is positive, then according to our definition, if this is positive, then this right here has to equal this other side. So they are equal. So in other words, I would have this situation. 3x plus 2 has to equal 4x plus 5. So this is positive right here. Then the absolute value of that would have to equal this. So that means that this and this have to be equal. All right? If this is, let me do it this way. If this is negative, okay? If this is negative, now remember the absolute value of number is always positive or 0, right? So this is positive. And if this is negative, then what I've got to do is notice that those are opposites. Those are opposites. And so therefore 3x plus 2 and this are opposites, so I have to take the opposite of the other side, 4x plus 5. And so that's how you're going to deal with this. So basically, whenever you have, and you do it just like you did this one. So compare this with this. So when you rewrote this, you said 3x plus 2 has to equal 5, and then 3x plus 2 would equal the opposite of 5 as well. Because this expression, if this expression right here is positive, then that means this and this have to be equal. If this expression is negative, in order for it to be positive, I got to take the opposite of this side right here, because they're opposites. All right. And so you just solve each linear equation. So let's go ahead and subtract 3x from both sides. And so I get 2 equals x plus 5, and then subtracting 5 from both sides, I get 2 minus 5 is a negative 3 equal x. All right, now let's talk about this. So now that I have variables on both sides, right? I have variables on both sides. So remember, in my previous example, this right here was positive. So I knew that since this is positive, then these are going to be my solutions right here. But the problem is that this variable, that there's a variable on this other side right here, the side that does not have the absolute value equations. So I need to check the solutions in the original equation because I may introduce what's called extraneous solutions. And you had that word in a previous lesson when we dealt with rational equations. So remember, an extraneous solution is a solution that is not a solution to the original equation. This, and we sometimes call it proposed solution or apparent solution. This apparent or proposed solution cannot be a solution to the original equation and therefore is rejected. Sometimes we refer to this apparent or proposed solution as a false solution. So you have to remember this. Whenever you're dealing with absolute value equations and there are variables on both sides, and this side has an absolute value and this side does not, you have to check for extraneous solutions. You must check for extraneous solutions. All right? So I have x equal -3, so I'm going to come back. I'm going to check for this in a little while. Let's go ahead and solve for this one. So to solve this equation, I'm going to distribute the -1 here. And so I get 3x plus 2 equal -4x. So the opposite of the opposite of 4x is -4x. And the opposite of +5 is a -5. And so I'm going to solve this linear equation. I'm going to add 4x to both sides. And so 3x and 4x is 7x plus 2 equal -5, right? And then subtract 2 from both sides. I get 7x equals, this is 0. -5 and -2 is a -7. Divide both sides by -7. I get x to be -1. All right. So I've got to check because I had variables on both sides, and this expression here could be positive, negative, or 0. Okay? So let's check this. You got to check. You must check for extraneous solutions. I did not have to check here because this was positive. All right? And so since I knew this was positive, I knew I would have two solutions. I would have solutions, and those two numbers would be solutions. But here, I am not so sure. I've got to check. Because this side's always positive or 0, right? But this, because of the absolute value. But this side could be positive, negative, or 0. All right? So this side can never be negative. Okay, so let's check this one. So you must check. So let's check x equal -3. So go back to the original equation. Now remember what we meant by extraneous, just to remind you. So an extraneous solution is a solution that is not a solution to the original. So you see this x equal -3? It's a solution to this linear equation. So that is a solution to this. That's true. And the x equal -1 is a solution to these linear equations. But the question is it a solution to the absolute value equations? See, an absolute value equation is not a linear equation. It's an absolute value equation. These are linear equations. All right, so we must check. Okay, so here's the original. The absolute value of 3x plus 2 is equal to 4x plus 5. So wherever I see the variable x, I have to substitute -3. So I have the absolute value of 3 times -3 plus 2 equal, and I want to see if that's going to equal 4 times x, which is -3 plus 5. All right, so let's look on this side. So 3 times a -3 is a -9. So I have the absolute value of -9 plus 2. -9 plus 2 is a -7. So that's an absolute value of -7. And the absolute value of -7 is a +7. On this side, I have -12 plus 5, which is a -7. And notice 7 and -7 are not equal. So x equal -3 will not be a solution. So this is considered an extraneous solution. Okay? All right. So let's go to the other one. Let's check x equal -1. So when I check x equal -1, let's see what we get. So go back to the original equation, which is this. And wherever we see the variable x, I'm going to substitute -1. So I have 3 times -1 plus 2, the absolute value of that. And I want to see if that's going to equal 4 times -1 plus 5. 3 times -1 is a -3, right? And then -3 plus 2, but remember, we're thinking absolute value, and so -3 plus 2 is a -1. And we know that the absolute value of -1 is a +1. Over here, I have 4 times -1 is a -4, and -4 plus 5 is equal to a +1, and notice those are equal. And so x equal -1, so the only solution is x equal -1. That's the only solution. All right, so notice the work you had to do. So if you have variables on both sides, notice on the left side or on one side you have absolute value, on the other side you don't. So you are going to have to check for extraneous solutions. And you do it just like you did the previous lesson, the idea behind the previous lesson. So if this is positive, then this and this are equal. If this is negative, then this has to equal the opposite of the other side. And that same idea here. So if this expression is positive, then this and this must be equal. If this expression is negative, then this expression and this side must be opposites. So in order to make them equal, we have to take the opposite of this side of that expression. But you must check. Don't forget to check for extraneous solutions. All right, so notice that this absolute value equation, which led to two linear equations, only had one solution right here. The other one was extraneous. And we knew that because we checked. So you must check. You must show that you checked. All right, let's look at number 2. So let's do another one. So let's look at number 2. So number 2, let's suppose we had this for number 2. So let's suppose we had the absolute value of 5x minus 2 is equal to 2x plus 1. So again, notice I have an absolute value equation. I have absolute value on the left side by itself, and on the other side, I don't have absolute value, but I do have a variable expression. So I know I'm going to write this as two situations, right? So situation 1 would be that if this is positive, if 5x minus 2 is positive, then this expression and this expression had to be equal. So 5x minus 2 must equal 2x plus 1. But if this is negative, in order for this and this to be equal, and this is negative, then I've got to take the opposite of the other side. So I get 5x minus 2 is going to equal the opposite of the other side. So don't forget to do that. Make sure you put that in parentheses, because both of those terms have to be multiplied by -1 at some point. So notice I went from an absolute value equation to two linear equations without the absolute value bars. And then you just solve each of those equations. So let's go ahead and solve this one. So I'm going to subtract 2x from both sides. 5x minus 2x is 3x. Minus 2 equal, this is 0, that's equal to 1. Adding 2 to both sides, I get 3x equal 3. 1 plus 2 is 3, and so therefore x is 1. All right, but remember, you must check for extraneous solutions. Extraneous solutions. Or roots, sometimes we call them roots. And you must check because this side, I'm taking the absolute value of this expression, so we know that this is going to be positive 0. But this side could be positive 0 or negative. So this side will never be negative, so I have to make sure that this side's not negative either. Okay? All right, let's go ahead and solve this linear equation. So I get 5x minus 2 equal, and the opposite of 2x is a negative 2x. The opposite of a positive 1 is a negative 1. And let's go ahead and add 2x to both sides. And so 5x and 2x is 7x minus 2 equal, this is 0, negative 1. Adding 2 to both sides, I get 7x equal, negative 1 plus 2 is 1, so therefore x is 1/7. Divide both sides by 7. All right, so let's go ahead and check both of those solutions. So remember, those proposed solutions are those apparent solutions, or solutions to these linear equations. So this is a solution to this, and this is a solution to these linear equations right here. But the question is, are they solutions to the absolute value equation? All right, so let's check it. So you must always go back to the original equation. So let's check the first one. Check x equal 1. So the absolute value of 5x minus 2 is equal to 2x plus 1. So in place of x, I'm going to substitute 1. So I get the absolute value of 5 times 1 minus 2. And I want to see if that's going to equal the other side. So it'll be 2 times 1 plus 1. 5 times 1 is 5. And so I get the absolute value of 5 minus 2. 5 minus 2 is 3, so that's absolute value of 3. And we know that the absolute value of 3 is 3. On this side, 2 times 1 is 2, and 2 plus 1 is 3. So they are equal. So x equal 1, this proposed solution or this apparent solution is a solution to the absolute value equation. Now I've got to check this one. So let's check x equal 1 7. So in place of, so let's go back to the original equation, which is this. And wherever c, the variable x, I'm going to substitute 1 7. So I have 5 times 1 7 minus 2, absolute value of that, and I want to see if that's going to equal 2 times 1 7 plus 1. Well, 5 times 1 7 is 5 sevenths. So that's the value of 5 sevenths minus 2. And let's go ahead and figure out what 5 sevenths minus 2 is. So you know that 5 sevenths minus 2, the absolute value of that, means the same thing as, remember the LCD is 7, so it means the same thing as 5 sevenths minus 14 sevenths, right? 14 divided by 7 is 2. Well, 5 sevenths minus 14 sevenths is not negative 9 sevenths. So that's absolute value of negative 9 sevenths. Well, we know that the absolute value of negative 9 sevenths is a positive 9 sevenths. So this left side is a positive 9 sevenths. Now let's check this side. So 2 times 1 seventh is 2 sevenths plus, and then 1 I can write as 7 over 7. And then 2 sevenths plus 7 sevenths is 9 sevenths, and notice they are equal. So in this situation, both of those solutions work. So I don't have any extraneous solutions. So you checked for extraneous solutions. Here's your work for checking, and then you saw that both of them work. So the solutions are x equal 1 and x equal 1 7. Okay? All right, so that's number 2. Okay, let's look at number 3. So number 3, let's suppose we had this for number 3. All right, number 3. Let's suppose we had the absolute value of 5 plus 2x is equal to 4 minus x. All right, so again, I have absolute value equation with variables on both sides. One side has absolute value bars, the other one does not. So I know in this particular case, I can think of this as 2 situations. First situation would be that in order for this statement to be true, if this is positive right here, obviously this is positive. If it, whatever makes this work, this is going to be positive or 0. It will never be negative if this is positive. So if this is positive, then I know that this and this have to be equal. So 5 plus 2x must equal 4 minus x. But if this is negative right here, in order for this, if this is negative, in order for this to equal this, I've got to take the opposite of this. So 5 plus 2x must equal the opposite of 4 minus x. All right. So then notice I went from an absolute value equation to 2 linear. So I'm going to go ahead and add x to both sides. So I get 5 plus 2x and x is 3x equal, this is 0 and you're left with 4. Subtracting 5 from both sides, I get 3x equals 4 minus 5 is a negative 1, so x would be a negative 1/3. Over here, I'm going to go ahead and distribute the negative, and so I get 5 plus 2x equals, the opposite of 4 is a negative 4, and the opposite of a negative x is a positive x. And then let's go ahead and subtract x from both sides. I get 5, 2x and a negative x is a positive x equal, and then this is negative 4. Subtract 5 from both sides. I get, let's see, that'll be x equal negative 4 and negative 5 is a negative 9, right? And so this solution here is a solution to these linear equations. This solution here, x equal negative 9, is a solution to these linear equations. Now the question is, are these solutions to the original? So you must check for extraneous solutions. All right. So whenever you have absolute value equations and one side has absolute value bar and the other one does not, it could happen that this side could be negative, so you got to check for extraneous solutions. All right, so let's check x equal negative 1/3. So check x equal negative 1/3. All right, when I do that, I get, let's see, so let me go back and rewrite the original problem. So it'll be 5, the absolute value of 5 plus 2x equal 4 minus x. So wherever we see the variable x, I'm going to substitute negative 1/3. So I have 5 plus 2 times negative 1/3. And I want to see if that's going to equal 4 minus a negative 1/3. So on the left side, 2 times, remember you multiply before you add, so 2 times a negative 1/3 is a negative 2/3. So you have 5 plus a negative 2/3. Well, 5 plus a negative 2/3 is really 4 1/3. And the absolute value of 4 1/3 is 4 1/3. Over here, 4 subtract a negative 1/3 means 4 plus 1/3, which is 4 1/3. So both of those are equal. So x equal negative 1/3 is going to be a solution. Let's check negative 9. All right, so we're going to check x equal negative 9. And so the original equation is the absolute value of 5 plus 2x equal 4 minus x. So in place of x, I'm going to substitute negative 9. So I have the absolute value of 5 plus 2 times negative 9. And I want to see if that's going to equal 4 minus a negative 9. Well, 2 times negative 9 is a negative 18, so that becomes 5 plus a negative 18. 5 plus a negative 18 is a negative 13, right? And the absolute value of negative 13 is a positive 13. Over here, 4 subtract negative 9 becomes 4 plus 9, which is a positive 13, and those are equal. So these two are going to be solutions. So I didn't have, again, in this example, I did not have any extraneous solutions at all. So both of those are solutions. So the solutions are x equal negative 1/3 and x equal negative 9. All right, let's do one more. All right, one more. And the one we're going to do, by the way, so it is possible for you to not have any solutions. So that'll be number 4. So let's look at number 4, because I want to do one where there are no solutions. So let's see what we get when we have an equation in which there are no solutions. All right, so let's look at this one. So we have the absolute value of 1 minus 2x is equal to x minus 3. So I have absolute value equation, variables on both sides. One side has absolute value bar, the other one does not. So remember, the absolute value of a number, whatever value I put in here, this absolute value is always going to be positive 0. This could be positive 0 or negative. So I got to be careful when this is negative. All right, so in order for those two sides right here to be equal to each other, if this is positive, if this expression is positive, then this has to equal this. So in other words, 1 minus 2x must equal x minus 3. If this is negative, in order for those two sides right here, the absolute value equal x minus 3, if this is negative in here, then those two expressions are opposites. So that means that 1 minus 2x has to be the opposite of x minus 3. So 1 minus 2x is going to be the opposite of x minus 3. And so I went from an absolute value equation to 2 linear equations. And so I just got to solve each of those equations. So let's go ahead and add 2x to both sides. And so I get 1, this is 0, equal x plus 2x is 3x minus 3. Adding 3 to both sides, I get 1 plus 3 is 4, so I get 4 equals 3x. And then divide both sides by 3, I get x to be 4/3. Okay? And so on the other side, I get, let's go ahead and distribute the negative 1 in here. So I get 1 minus 2x equal, the opposite of x is negative x, and the opposite of a negative 3 is a positive 3. Adding 2x to both sides, I get, this is 0. When I combine like terms, I get 1 equal negative x plus 2x is x plus 3. subtract 3 from both sides, I get negative 2 equals x, right? All right, so let's check. Let's check for extraneous solutions. All right, so remember, x equal 4/3 is a solution to each of those linear equations. Same thing here. X equal negative 2 is a solution to each of those linear equations. But are they solutions to the absolute value equations? So that's why you have to check for extraneous solutions. All right, so let's check x equal 4/3. Go back to the original. The absolute value 1 minus 2x is equal to x minus 3. So in place of x, you're going to substitute 4/3. So I get the absolute value 1 minus 2 times 4/3, right? And I want to see if that's going to equal 4/3 minus 3. Well, 2 times 4/3 is 8/3. So that's 1 minus 8/3. That's the value of that. The LCD is 3. So I can rewrite 1 minus 8/3 as 3/3 minus 8/3. 3/3 minus 8/3 is a negative 5/3. And the absolute value of a negative 5/3 is a positive 5/3. Over here, I have 4/3, and then the LCD is 3, right? So 3 is the same thing as 9 divided by 3. 4/3 minus 9/3 is a negative 5/3, and those are not equal. So therefore, x equal 4/3 is extraneous. So that's an extraneous root, or an extraneous solution. Now let's check x equal negative 2. All right, so in x equal negative 2, go back to the original, and you have the absolute value 1 minus 2x is equal to x minus 2. So in place of x, you're going to substitute negative 2. So I get the absolute value 1 minus 2 times negative 2. And I want to see if that's going to equal negative 2 minus 2. All right, so I get the absolute value 1 minus 2 times negative 2 is a negative 4, right? 1 subtract negative 4 means 1 plus 4, notice absolute value. 1 plus 4 is 5, and the absolute value of 5 is 5. Over here, I get 2, I'm sorry, that's a 3 right here, excuse me, 3. All right, let me make a 3 here. And then, okay, so negative 2 and a negative 3 is a negative 5, and notice 5 does not equal negative 5. And so this is extraneous as well. So notice in both of those equations here, those proposed solutions, these two proposed solutions, negative 2 and 4/3, or those apparent solutions, both of those are not solutions to the original. So therefore, we're going to say there is no solution. All right, so you have to say no solution. All right, and so that is the work. So that's how you're going to solve absolute value equation where there are variables on both sides. It is very similar. The idea is the same as what you did in a previous lesson. Okay? All right, so that is it.